Welcome to the Bentley Systems training course, where we will discuss topics on how to push a RAM structural system building model to the iTwin Analytical Synchronizer using the local file workflow. In this particular video, we'll review the concrete members and walls in our newly created iTwin repository. First, let's go ahead and review our curved member objects in our repository. Now, the curved member objects will include all of your piles, columns, beams, and braces. In addition to that, all of your slabs and walls will be pushed to the iTwin Analytical Synchronizer as surface member objects. Now, for this particular video, we're going to focus our attention on the concrete and reinforcement that was sent from RAM structural system after the analysis and design was performed. Now, you can focus your attention in the iTwin Analytical Synchronizer using some of your filtering tools. Like, say for example, I only want to see my concrete elements. Here I can unselect the analysis, load cases, and steel information, and what will be left will be my concrete information. Now, if I wanted to take that a step further, I can select which items exactly I want to go ahead and see right now. So here I've told the model I want to see my concrete. Let's go with our wall information. And if I scroll on down, we can choose whether or not we want to see the grids and the reinforcement information. So now in my model, I'm focusing my attention on all the main concrete elements that were designed in RAM concrete. This will include all of the concrete members, concrete walls, and the reinforcing steel that was designed in RAM concrete. Now, with any type of object that is sent from your analysis or design program to the iTwin Analytical Synchronizer, the properties that define that object will also be sent, and they'll be assigned in the iTwin Analytical Synchronizer. Now, I do think it's a good idea to go ahead and review this information so you know where all of it is stored, and you can interpret your iTwin model a lot easier, and you'll also know how that information will go into another analysis and design platform. So let's go ahead and start with our concrete members. So here I'm going to go up to our curved member objects. Now, as previously stated, a lot of objects are identified as a curved member object, and you can go ahead and focus your attention in the objects window by doing some filtering as well. So what I can do is I can go ahead and apply some additional filters if I want to see just certain types of objects within the objects window. That might make it a little easier for me to find the information I'm looking for. So the first thing I'm going to do is I'm going to go to this type field. I can say I want to see just my curved members. Then I can go to the label field, and this will be filtered on just curved members. And what I'm going to do is go ahead and say, yeah, I just want my concrete ones. So I'm going to go ahead and identify which ones those are that I would like to see. Once I'm done, I can go ahead and click OK, and you'll see that this list will now be truncated to just the elements that you're interested in. Let's go ahead and select one of the columns in our model, and we're going to do that by just selecting its checkbox. You could also alternatively select it in the main window. So here we're going to see a variety of different fields in the Properties dialog at the bottom of the screen that's used to identify this member, and this information was populated from the information you entered into your RAM structural system building model. The first field we're going to see is your load resistance field. Now, this indicates the framing property that was assigned to each member in the RAM modeler. So in RAM structural system, we are going to define each member with its framing category as either gravity or lateral, depending upon the type of forces you believe it's going to resist. This column that I've selected right now is identified as a gravity member, so you can see it's saying gravity only. Let's go ahead and move on down, and we're going to find the system kind field. Now this indicates the type of material that was used to model the member in RAM structural system. The two main materials we have available in RAM structural system are steel and concrete. You can also define members using the other material property, where you're going to manually enter your material properties in, or also as steel joists. Of course, we are focusing our attention on our concrete members. Next, we're going to take a look at the use field. Now this indicates the type of member that this member was defined as in RAM structural system. It'll either be specified as a beam, a column, or a wall for your vertical force resisting system. Let's go ahead and scroll on down in our properties dialog. And what we're going to notice is that each member will have a field of related items that are assigned to them. This will include your material properties and section properties. Now whenever you have something over here that has an underline under it, it means that that information to define that material or that section property or so forth is also defined in another area. So here I could see that the 4,000 psi concrete has been assigned to this particular member. If I go ahead and click on that, I will take me to the concrete material property that's defined as 4 KSI, and I'll be able to see all the information that was used to define that member, including your Poisson's ratio, your compressive strength, and so forth. To return back, I'll go ahead and click on the back arrow, and I can also review your section properties. Now in RAM structural system, the section properties for your concrete members are defined using the section properties table, and then this information was taken from that RAM structural system model. Let's now focus our attention on the concrete slabs that were brought over from RAM structural system. And to start that process, I'm going to go ahead and clear all my filters, and then I'm going to focus on my surface objects. Let's take a look at our surface objects, and I'm specifically looking for my slab information. And my walls. So here you can see I've identified my surface members and my walls. Right now I'm not seeing them because of this filter has now been set, so let's go ahead and turn on our slab information. Okay, so here I'm going to go ahead and select one of my wall members. You're going to notice on your screen your wall object is now highlighted to show you which wall you're actually taking a look at. Again, we're going to see the same load and resistance field has been specified, the same system kind and use type fields. Okay. In addition to that, we'll also be able to see the thickness of our wall that was defined in RAM structural system. We will see our surface offset and our placement point. We'll go ahead and scroll on down, and we'll see the material properties have been assigned to it. Now the last type of object that we're going to take a look at when we're talking about our concrete model within RAM structural system is the reinforcement that was designed in either RAM concrete or RAM foundation. Now reinforcement for concrete beams, columns, shear walls, and rigid foundations will be pushed to the iTwin Analytical Synchronizer as a variety of different rebar objects. Here, for example, you could see area surface rebar. This would be used for your shear walls. Now, if you'd like to filter on those types of objects, what we can do is go ahead and search for anything that's called rebar. Here we can see all search results. Let's go ahead and select that and click OK. Now here what we're doing is we are focusing our attention on anything related to the rebar, including the rebar parameters. Let's take a look at some of those area surface rebar information. So here we'll be able to see the rebar hook information, the rebar direction, the spacing, and so forth. If you want additional information on that material, here you can see it was specified as a number 5 bar. I can see the area and diameter of the bar as it was defined, including the yield stress. Now at this point, this concludes our process for reviewing the concrete members that were pushed from an analyzed and designed RAM structural system model to the iTwin Analytical Synchronizer using your local file workflow.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.